Hi everyone, welcome back to our channel. Today we are going to perform the theoretical calculations of y parameters. Okay, so here we need to find out y11, y12, y21 as well as y22. So here this for this given T network we will perform theoretical calculations currently in this video continued with a practical video on calculation of y parameter. Let us first see how to calculate these parameters. Okay, so here in order to find it, basically we need to know the basic equations. The basic equations for y parameters is I1 is equal to y11 v1 plus y12 v2, and the second equation for current is I2 is equal to y21 v1 plus y22 v2. So here to find the value of y11 y21, I'm going to make v2 is equal to 0. When we make v2 is equal to 0, then so this term will become 0. Then the value of y11 is equal to I1 divided by v1, and the next term y21 is equal to I2 divided by v1. Okay, so the next term is v2 is 0 initially. Now we will make v1 as 0. So when v1 is equal to 0, I mean these terms are 0, then the value of y12 is equal to I1 divided by V2, and the value of y22 is equal to I2 divided by V2. Okay, so these are the y parameters what we are going to get. So now let's try to solve it. The first step of solving is nothing but we need to make output port as 0 is nothing but V2 equal to 0. The meaning of V2 is 0 is output port is short circuited. Output port is short circuited, so automatically you can see here this port will be 0. Now let's try to redraw the network. Okay, so we are exciting v1 with a voltage of 30 volts, 0 volts, and we are going to have an 820 ohms, and we are going to have a 510 ohms. Okay, and we are going to have the next resistor with a value of 2000 ohms. And now this, as I told, v2 is 0. So whenever v2 is 0, the meaning here is this is short circuited, so v2 is equal to 0 volts. So now we need to find out the which parameters is so we need to find out y11 is equal to I1 divided by v1. Okay, and next parameter what we need to find out is y21 is equal to I2 divided by v1, but in the given problem what is given is v1 is given. Okay, so I can say that so v1 is of 30 volts, and V1 in the denominator is also 30 volts. The term what I need to determine is nothing but the value of I1 as well as I2. Okay, so how to find this is very simple. Okay, so in order to apply it, let's try to do it with this marking of currents. So let us try to mark this voltage as some. Let's try to mark this node as some Vx, and just I am for a simpler analysis I am assuming the current of I1, the current in this branch as I2, the current in this branch as some Ix. Okay, so what is this way of solving is so let us try to apply nodal analysis. Okay, so the first step of solving is applying nodal analysis. Apply nodal analysis at the node Vx. When we apply the nodal analysis at Vx, the entering currents and leaving currents, there is no entering current, and the leaving currents are like 0 is equal to I1 plus I2 plus Ix is equal to 0. Therefore, 0 is equal to I1. So how to write down the current is the current I1 is flowing in this direction. Okay, so this I can write down as Vx. So and leaving terminal is Vx, and the next leaving terminal is minus. So Vx minus 30 divided by 820 ohms. And how to write down the current I2 is, so the current I2 which flows in this branch, I can write down it as Vx minus 0 divided by 2000 ohms. Okay, plus Ix. So what is the current in this branch? Ix I can write down it as Vx minus 0 divided by 510 ohm. Okay, so now this will give an equation. Just take Vx as an common term and try to solve it. Okay, so when you take this Vx as an common term, then you are going to get the expression like this. Okay, so let's try to solve it. So take Vx as an common term, and you are going to get 30 divided by 820 volts is equal to Vx is common, then which is 1 by 820 plus 1 by 2000 plus 1 by 510. So now just use your calculator, then you will be getting this value. So therefore, using the calculator, then you are going to get the Vx as 10 volts. Okay, so therefore the unknown voltage is 10 volts. Just substitute this Vx is equal to 10. Okay, so when you substitute, 0 is equal to 10 minus 30 divided by 820 plus Vx is how much? 10 divided by 2000 plus 10 divided by 510. So 0 is equal to, you're going to get minus 24 milliampere plus 5 milliampere plus 19.6 milliampere. When you add this, then you're going to get this resultant. So now this is the value of I1, and this is the value of I2, and this is the value of Ix. Okay, now just substitute in the all these equations, then you can get it. Okay, therefore the value of Y11 is equal to I1 by V1, I1 divided by V1. So here you can see here I1 I had taken in this direction. Okay, so when you redraw it, you can understand better. So this is 820, this is 510, and this is of 2000, and this is shorted. So if I1 is flowing like this is nothing but positive value. I1 is flowing in this direction, then this will be positive. You can see here I1 is how much? Minus 24. So if it is then it is minus 24. If it is in opposite direction, then it is plus 24 milliampere. Just very simple. If it flows in clockwise direction, 24 milliampere. If it flows in counterclockwise direction, minus 24 milliampere. That's how the simple analysis we have to keep it in the mind. So therefore y11 is equal to I1 by V1. So I want the value of I1 which flows in forward direction, which is 24 milliamperes divided by V1. How much I applied is 30 volts, and I want the value of y21 is equal to I2 divided by V1. The value of I2 is 5 milliamperes divided by 30 volts. Therefore, here you are going to get as 0.8 millimos, and 5 by 30 you are going to get it as 0.166 millimos. Okay, so here the tabular column you are going to get like this. Now let us try to draw the tabular column to what we are going to get. So this is the tabular column. So in this tabular column, you are going to get the theoretical calculations, and you are going to get the practical calculations at the top. So here what is 0 we assumed here is the first term. What we assumed 0 is here is V2 is 0. So we have to write down V2 is 0 means output port is short circuited. Then we are going to get, so when V2 is 0, what are the values we had find out? So V1 we have to write down the corresponding value. And we want to write down the v1 value as well as the value of I1, the value of I2. So V1 is very clear. V1 is how much? 30 volts. I1 is how much? What is the value of I1? So I1 is nothing but which flows in this direction is 24 milliamperes. This is 24 milliamperes. But the value of I2 is 5 milliamperes. So when you do the experiment, same you will be getting similar to that of this theoretical you'll be getting, then you can get the values of y11 and y22. The same problem we are going to do in reverse by making the opposite direction. Okay, so see here, just now I am going to copy the same problem and I'm pasting the problem here. So now this is the problem given. So already we had seen here. So here we have to make v1 is 0. Okay. So when you make v1 is equal to 0 here, how we are going to get is also very much important. Okay. So for this circuit, we have to make v1 is 0. Okay. When v1 is 0 means, so try to do these calculations. v1 is 0 means which indicates that input port is short circuited. So now make input as short circuit. So now I am making v1 is equal to 0. Then I am going to get the value of a resistor is 820 510. So this is 820 ohms. This is 510 ohms. This is 2000 ohms. So 2000 ohms, and here you are going to get the applied voltage of 30 volts. So this is the value of V2. Now when V1 is 0, let's try to solve it. We have to find what are the values we need to find out is y12, which is nothing but I1 divided by V2, and we need to find out y22 is equal to I2 divided by V2. Okay, so the value of V2 is already known to us. The value of V2 is 30 volts and the value of V2 is also 30 volts. We need to find out the value of I1 and the value of I2 from the problem. Okay, so for simpler analysis, I am writing the currents in my suitable form. I am assuming this as I1 and the current in this direction as I2 and the current which flows in this direction as Ix, and already the voltage here is 0. The voltage at this point is 30 volts. It will create a new node which is nothing but at this point is Vx. So now to hand find I1 and I2, let us try to apply nodal analysis. Apply nodal analysis at node Vx. Okay, so when you write down the nodal analysis, is indirectly applying KCL. Okay, apply KCL. When you apply the KCL, what are the entering currents and leaving currents? At this point, you can see here, there's no entering currents, all are leaving currents. 0 is equal to I1 plus I2 plus Ix. So 0 is equal to I1. So how to write down the current I1 which is flowing in this branch? The current which is flowing in this branch is, I can write down I1 as Vx minus 0 high potential minus low potential divided by R. R value is how much? 820 plus how to write down the current I2 which is flowing in this branch is like this. Okay, so which is nothing but Vx, current is leaving, what is the leaving terminal of the voltage? High potential minus low potential, 30 divided by R. R value is 2000 plus Ix. How to write down the current in this branch? I can write down it as Vx minus 0 divided by 510. So here you can segregate the terms and you will be getting as 30 divided by 2000 and take Vx as an common term. So that is equal to Vx as an common term 1 by 820 plus 1 divided by 2000 plus 1 divided by 510. So like this you are going to get like this, and by using a calculator you can solve it. So then we are going to get the value of Vx is equal to 4 volts. Okay, the value of Vx at this point we obtained is 4 volts. Just substitute this in this above equation, then detail you will be getting. So 0 is equal to 4 minus 0 divided by 820 plus 4 minus 30 divided by 2000 plus what is the value of Vx? 4 divided by 510. You can see here when you solve with a calculator, then this you are going to get it as 4.87 milliampere. This one negative will be getting minus 13 milliampere plus 7.84 milliampere. When you add all these things, the resultant will be equal to 0 amperes current. This current I am going to label as I1, this current I am going to label as I2, and this current I am going to label as I1. So when you see here, so what is the value of V1 we obtained is 4.87 milliampere, and what is the value of I2? So let us try to take I2 with the taken like this. In this direction, this is minus 13 milliampere. If it flows in this direction, it is plus. Just take it as plus. So which is nothing but 13 milliampere. So when you solve it, you are going to get it as 0.16 millimole, and here you are going to get 0.433 millimole. Okay, so like this you are going to get the resultant values of, so the value of y11 is known, y12 is known, and y12 is equal to 0.16 millimole, and the value of y22 is equal to 0.433 millimole. So this is the solution what the question asks: determine the y parameters for the given network. So this how we are going to get the y parameters. And now let us try to draw the tabular column what is required to do the practical. Okay, so in this tabular column we are going to get the first row as theoretical calculation and the second row as practical calculation. And here what we have been short circuited is, so here V1 is equal to 0, which meaning is that input port is short circuited. Okay, so when V1 is 0, what are the values we have to tabulate is V2 value. Okay, so V2 have to tabulate, and I have to tabulate the value of I1 as well as I have to tabulate the value of I2. Okay, V2 value is how much? 30 volts. I1 value is 4.87 milliampere. I2 value is 13 milliampere. So do the practicals, then you'll get similar up to this value. Then please substitute, then you are going to get the resultant y parameters of the given network. This is the resultant y parameters of the given network. Hope you are able to understand the problem. So please give one like to support us to do more videos, and please share with your friends, those who are your classmates studying the same subject. And if you're watching my channel for the first time, subscribe to my channel with the name KV Tulasiram, and kindly encourage these kind of free channels for the development of students as well as for the faculty. Thank you for your help and support for watching. We'll meet in the another video. Yours obediently, Ram.